The three of us previously worked together at Kepler Technologies, a company focused on raw industrial data collection and is now part of the PTC family. HighByte's mission is to provide the critical infrastructure for bridging the gap between the raw data collection and the many disparate applications that need to make use of refined industrial information. Industry 4.0 is adding new types of applications that solve a variety of important use cases around enterprise-wide visualization, asset management, and supply chain optimization, just to name a few. More often, in a single site, these applications come from multiple vendors. And if they don't, they most certainly will when you connect to multiple sites that were deployed at different periods of time and by different personnel or businesses. As such, each application has its own demands on the structure and the format of the information it requires in order to provide value. Learning a new way of representing the same types of information is not only tedious, but it's not scalable nor maintainable in the long term, especially as the environment changes over time. Deploying a new app should be focused on the additional value it provides, not the repetitive efforts of configuring, segmenting, and massaging the same data for a different purpose. We believe that like a successful data collection platform at the bottom of the stack, there's also a need to abstract away how information is modeled at the top of the technology stack. This entails the creation, maintenance, and deployment of a single set of data models from a centralized location that can automatically be transformed into the requirements of the various applications. These information models can represent assets, products, processes, or systems, anything really. And only until you can manage and make this available information from a central repository, or what more and more people are referring to as a unified namespace, can you ensure that information will be consistently represented across the enterprise? That's a lot of words. So how about a picture that further illustrates the problem? As you can see, the Industry 4.0 technology stack has some clear and well understood types of applications, from IoT platforms, ERP, to quality management systems and cyber threat monitoring systems. The stack also has some well understood sources of data, from PLCs and gateways to outfitting just about anything you want with smart sensors. The complexity lies in the raw data collection by all applications, each of which needs to standardize, normalize, and assemble the raw data being collected, and then adding any context-aware information that's needed on an application-by-application basis. Of course, in addition, not every application or user within an application session should have wide open access to all data. So being able to easily turn off access when and where needed is also critical. Adding a new sensor to monitor a new variable is easy, until you are required to modify as many applications as you have in use to get the full value of a new insight. In addition to other Industry 4.0 applications we just covered, more and more manufacturers are working to deploy analytics, machine learning, and other types of algorithms into their systems. There are many benefits being sought out with an analytic strategy. One benefit is reducing the cost of maintenance and machine downtime with predictive maintenance strategies. There are probably, hopefully, very few manufacturers that run till failure these days, and instead have incorporated the scheduling of downtime to care for their machinery in an effort to prevent unexpected failures. But the rub is, did I really need to perform maintenance on that today, or would it have been fine running for another 6 months? Through existing automation and the addition of new cost-effective IoT sensor solutions, it's very easy to grab some machine-specific data that can be used as an input to better gauge or predict when is the right time to perform maintenance. The same data may be interpreted a little differently and also allow for productivity improvements, optimization, and the use of one or more assets across a number of sites. Outside the plant floor, analytics built into the manufacturing products can provide customers with higher levels of satisfaction. Here, manufacturers can instrument the use of their products in an effort to better understand customer needs and ultimately provide a higher quality product and service. Likewise, analytics can provide a manufacturer better insights into the entire business, driving performance and scheduling needs, and allowing for it to better plan for future demand. You can see how these new insights, like customer satisfaction or demand, can also be inputs re-injected into other systems. So in a sense, we do not just collect data, model it, and provide value within a specific application. We need to take these new learnings and continuously iterate over them, further closing the loop on how information is shared between various components in the architecture. Also, analytics is unique in that the data it needs might not come only from the various data sources we saw earlier, but even from some of the pre-existing applications, or worse yet, buried in technical documentation. This only exacerbates the complexity involved with modeling information sets from various data owners that need to be prepped and validated for correctness before being served to an analytic. So how is this solved today? Well, today, data scientists are spending up to 80% of their time preparing data for analysis. The one occasion when I actually mentioned this to a data scientist, they tell me it's probably closer to 90%. In consultation with the operations team and on an ad hoc basis, these data scientists are remodeling existing information for their unique analytics needs. They learn where the raw data lives and how to access it through technologies like we actually heard about yesterday, OPC UA or vendor-specific APIs. They learn how to normalize the raw data by peeking into existing SCADA systems and their associated scripting technologies that prescribe how to massage the data. They learn about data context from these same applications, as well as through technical documentation or by talking to plant engineers and other subject matter experts. They then develop their own custom code and pull all the types of data together and wrangle it into information that can be served into an analytic. After a heavy lift, they've made progress, but they now need to rinse and repeat this cycle in order to create the next one. They've also created a maintainability problem for the organization, another set of custom code. And without knowing it, a brittle solution due to the dependency on operations, and forever needing to be in the know on how changes made at the operations layer may need to be reflected in their work. This is only magnified when we look to future needs and other applications that we don't even know about today, but will also need to be integrated later in a future time. The industry knows there must be a better way. L&S, a leading analyst firm, consults with various manufacturers across various sectors. Working with the market, they've drawn out a system architecture for industrial transformation. From the left, we have a big picture view that illustrates data sources. These come from operations, suppliers, customers, and very common today, products. At the high end, we have cloud-based dashboarding, analytics, and collaboration tools built on various data storage technologies. And in the middle, we have all the integration work that pulls together the data collection and modeling needs. To the right of the diagram, we have a finer detailed view, including a lot of under the hood type technologies that may not be front and center to the end user, but are critical nonetheless. In fact, the market has begun to draw a line that introduces DataOps as the data operational layer that facilitates the sharing of information between technology, systems, and processes, and ultimately people. In order to plug these holes, manufacturers can look at the best of breed, purpose-built solutions that when networked together achieve the desired architecture. By coupling their architecture, they avoid vendor lock-in. If a particular piece of the solution no longer meets their needs, they can replace just a single piece in the overall puzzle and keep moving forward. HighByte's focus is on building an application-agnostic modeling platform for cleansing, normalizing, standardizing, and adding context that can be shared between all of these building blocks. Earlier this year, we introduced the HighByte Intelligence Hub to help manufacturers streamline their data architecture and reduce the time it takes to deploy new systems. This solution allows the company to abstract away how information is derived from raw data collection and other sources of data. By extracting this into a single location, the platform can automatically transform the information into a format that can be consumed by various applications. Today, these applications, for which there are many, must support the OPC UA unified architecture and MQTT standards. We're currently working on other types of APIs and formats, such as SQL support and Spark Plug, and interoperability standard on top of MQTT, both to release at the end of the year. Others will follow, and you can be sure that with little effort and any previous work, you'll just be able to flow this information into additional applications and services. Modeling allows you to standardize a naming convention. that's consistent across the entire enterprise. No more trying to understand how a piece of data maps into an entire solution. You can normalize the data as needed and add context. This is the information that tells the user more about the data. For example, something as simple as units, operating range, or location, before delivering a consistent and complete set of information to all applications. Whether you want to take a bottoms-up approach, starting at the sensor level and modeling upwards, or a top-down approach, starting at the site and modeling downwards, how you model is entirely flexible. And you no longer have to own the custom code that needs to be maintained as the environment matures. Another important aspect to a central repository is that you can ensure information is assembled from the various data sources under a single set of conditions. This prevents the various applications of performing this task themselves and not having the same exact record of information across the board. This could be due to timing or other anomalies. The platform encourages reuse that further ensures standardization and adding little effort to scaling the solution. It runs on-premise, near operations equipment, and prepares the models for edge and cloud applications. As such, the platform is made for operations with oversight from other areas of the business that define standards. The platform provides a set of features that will resonate with the operations team. After all, they know operational data best and are responsible for long-term upkeep of their domains, keeping the rest of the business systems up to date whenever a change is made. Now at the time left, I'd like to provide a brief demonstration of the product. This demo is going to show you how to connect to various data sources and systems, how to model information, populate the models, and easily flow this out to a variety of applications. So I'm going to switch over to demo mode. So the first thing you do when you want to actually use the Intelligence Hub is you log into it with a specific user. In this case, I'm going to log as an administrator. There are really some primary concepts that hopefully you picked up on the presentation. We have the concept of connections, models, and flows, information flows. The first thing we're going to look at is connections. Connections are what ties us to the outside world, things like the OPC UA servers and the MQTT brokers. I've set up a couple connections in advance. We're actually going to publish information at an MQTT broker. This broker basically is going to have a couple outputs that basically are going to allow for feeds of building information as well as machine information. I've kind of pre-configured that before this demo. The next part is going to be actually collecting raw data points for an OPC UA server. Here we're actually going to go in and we're actually going to discover the raw data that's available to us. These tools are very familiar to operations. I'm going to go in and pick a few data points that we can use as part of this demonstration. The first part we're going to do is we're going to go into a plant and we're actually going to model a machine. And so I want some of its asset information that I'm going to pull in, as well as some of its operational data that I also am going to pull into our project. So you can see we have the asset ID, the date acquired, serial number, an operating temperature, and a running and a working process. Now these names themselves aren't very standard. In fact, to some they might be very ambiguous. Again, we're going to show how we can actually add standardization on top of this. In addition, in case we have time, I'm also going to actually show how we can reuse some of the things we're going to do in this demonstration by modeling some temperatures in a building. So I'm going to pull up a building and I'm going to grab some temperatures in the Munich building. And I'm going to pull some in Portland, Maine, our headquarters. As you can see, the naming conventions just here on how Munich decided to name their temperature control variables versus Portland are vastly different. We're going to import these into the project. At this point, I've made my pass to how we can actually go connect, collect, and where we're actually going to publish models to. So now the fun part, actually modeling. You'll notice that I already have one model here that I want to actually show how we can reuse. It's nothing more than an asset information block that has a few simple attributes, an ID, a serial number, and purchase date. So essentially every asset that I have, I want to standardize to have that same level of information. But the first thing I want to do is actually create a simple machine model. We'll call it a machine. And I'm going to actually define what the structure of a generic or this generalized machine is going to look like. The first thing I'm going to do is I'm going to actually bring in that asset info because that's just a requirement for my organization. This is an existing model that I can actually select right here in the modeling pane. The next thing I want to add is the online state of a machine, which basically is going to be on or off to tell me whether or not the actual machine is running or not. I also want to look at a utilization rate, which is going to be a floating point percentage to tell me how well the actual machine is operating. And lastly, I want to create an operating temperature. I know that one part of this machine is basically how hot it can run and that it could actually take down my plant. So I want to actually monitor that as well. Now, it'd be very easy to add this temperature as a floating point value, a real number that basically is just the current value. However, I may want to know its units and other types of attributes of that temperature. So in line here, I'm going to create a new model that represents a temperature that I can use elsewhere in my plant. This temperature is going to have a current value, and it's going to have units to start. At this point, I've actually defined what this machine is going to look like. And any machine that basically, real-world machine that basically resembles this is going to have the same standardization and outlook. Now we're going to go and populate this. We populate that by creating an instance. So again, think of an instance as a real-world representation of a machine that follows the model that we just created. So we're going to create one called machine X. And we're going to pick the machine asset that we basically model that we just created. And you can see we've already confined the user to stay within the standard that we developed. They have to go and create an asset information block specific to this machine. So if you remember correctly, when we first browsed that OPC server, we brought in some asset information. I'm going to go wire that up right now. Sorry about that. And we're going to basically pull in the purchase date as well. So that's the actual asset information. Now we're going to go wire up some of the online properties. And these two were also added in the beginning. We have an online state. We have a utilization rate, or what we call work in process at this site. And we had a current value. So we're going to actually create a temperature. We're going to actually assign the actual operating temperature associated with this machine. But we never had units as part of this particular underlying OPC UA server. So we're going to go add that context here. And in fact, we're going to standardize all temperatures, because this is Industry of Things USA, to degrees Fahrenheit. And I'm going to submit this model. At this point, we've wired up what was a real representation of machine X. Now we want to go and create the data flow that tells what conditions we should actually go and populate the model and publish it out for others to consume. That's through a data flow. I'm going to call this machine X for simplicity. I'm going to select the machine X model that we just created and populated. I'm going to pick that machine feed that we actually have as part of our broker. And I'm going to basically collect and populate this model every 5 seconds for this demo. And we're always going to do it regardless of the data changing. And I'm going to enable this. And I'm going to submit this. At this point, I'm going to actually pull up a third-party application that basically allows us to go and connect to MQTT. And you can see right out of the box, this application is automatically consuming the model that we have. It's very structured, very open. We're not trying to lock people into how data looks. This follows exactly the model they defined, a machine X, the type, and a lot of the attributes, both asset information and runtime stuff, already there. So that's great, but how about this reuse? What if I want to go and change what an operating temperature looks like, or if I want to use it somewhere else? So let's do that real quick. The first thing we're going to do is we're going to create a new temperature. I'm going to model the temperature at the Munich headquarters. Now we already created that temperature in line with machine, but it now is available as a separate model. I'm going to select that. And I'm going to wire up the actual Munich building temperature. Now, one thing I know is Munich actually is in degrees Celsius. So I can actually do a little bit of normalization here to get this in actual degrees Fahrenheit so that I can actually have that standard across my entire enterprise. And the units weren't there, so we're going to put those in as well directly into the platform. Now I just have to go create another flow so we can actually send this out to a building feed. We'll call this Munich. We'll go grab the Munich instance that we just created. We'll actually pick the building feed in this case, so we're publishing to a different application for all intents and purposes. We'll also do this at 5 seconds. And we will basically enable this immediately. So now what we're going to do is we're actually going to come up here and we should see temperature flowing as well. If I didn't actually code something up wrong. That's always the thing with real-time demos. That's funny. Great. Okay, well, I think, we're already at 1:22 past the hour. It looks like I've kind of, got the demo off the slide. I don't want to take everybody's time and try to figure that out. The goal here was that it's very easy to model something, be able to go and actually reuse those models and publish those into applications in a standard format that they can actually use. So with that, I guess I'd like to turn it over for questions.
Sorry. Yeah, thank you for the presentation. And of course, we also have some questions for you. I just saw that also another person who, of course, I think it was Ravi, who unfortunately wasn't able to hear everything in sync. A colleague of yours already reached out, so thank you for that. Thank you to John specifically. But one question that we got was just generally about the process, I would say. What would you say are the first and most important steps before you actually want to set up anything? Just really like in the beginning, if you want to implement a new digitalization strategy, so also keeping in mind to then further scaling it up, but what are maybe the biggest things that you have to check internally as a strategy before setting up, maybe checking what machines you actually have, what are the problems that you want to solve. Can you maybe like elaborate a little bit on maybe the first steps before implementing a new strategy?
Yeah, absolutely. I mean, the first thing is the last thing you want to do is start with a new tool and allow it to drive what you're going to do in your actual plan. I mean, never start with a product and say, okay, how can I make it work? So always start with the process of what are some things that I want to accomplish as an organization? And one of the things I talked to you was sort of a predictive maintenance strategy, where I want to go and basically wire up real-time data points, pull in certain metadata and context from a wide variety of applications, and then be able to run that through some analytical process, and then get the insights that I want that actually can, be worth my investment. And so I think the first place you start is, what's the problem domain that I actually want to solve at the highest level? At that point, you have to decide, okay, what are the steps that allow me to get that there? Am I going to use a complete solution from a single vendor that basically has a top to bottom solution? Or do I already have an environment, or do I want to be able to go and buy best of breed components, figure out how to stitch them together to be able to go and extend an existing solution, or basically, for my new needs? And so at that point, you start looking at the data architecture and saying, okay, what are the types of data or information that is replicated across my entire system? Because if I have 7, 8 different applications from different vendors that are looking at the same, representation of a machine, where should I go and manage that? And should I pull that out, abstract it, and basically, do that in such a decoupled way, if you will? And so, that's where I would start. And at that point, once you kind of work down that technology vision, if you will, then you start filling in the gaps and say, okay, what types of products am I going to use to basically simplify my technology stack, but provide some level of, agile capability as I grow?
Yeah, thank you very much. Thank you for that outline. Another question that we got was just in the sense of, if you already established something, what are usually the biggest issues or the biggest problems in regards to scaling? Because we also, yesterday we heard a lot about unicorn projects. So what are usually the biggest issues that you see with companies trying to then, scaling up?
Yeah, the biggest issue with scaling is, or at least that what we're seeing from the market and our customer base, is there's a lot of repetitive work, not in terms of just basically, recreating these models, but having to go in and rewrite custom code for every new problem that's encountered. And so, that actually is, a barrier to scalability, because, with every win, you have to start from the beginning and actually go and solve the next problem. And so, platforms like ours and other platforms that exist out there, or technology stacks, allow you to go and basically, create base level functionality that you can apply over and over again in such a way that you basically, scalability no longer becomes an issue.
Thank you. The last question that we got was more, I would say, in a regard of what you have a feeling on the industrial, just on the industry itself. Where do you see is still the bigger issue? Is it more that you have a lot of companies who still need to invest into digitalization and actually gathering all the data that they for now don't? Or is it more also on the maybe decision-making side that maybe people already start gathering the data that they would need, but they still struggle to get the right solutions out of that and actually have their operations teams look for the right numbers and actually distribute them in the right way that people also come to the right conclusions.
Yeah, I mean, if I understand the question correctly, I mean, it's a little bit of both, right?
Yeah.
What I would say is that, there are various companies that have already tried to sort of deploy sort of their IoT, industrial transformation architecture. They started trying to bundle in visualization and analytics. And they've been collecting data from, various data sources for some period of time and expect to be able to go and make intelligent decisions around that data. Unfortunately, the data isn't always clean. Basically it's missing samples, or in some cases, there's bad quality data associated with downtime or other events that might happen. And so, going back and figuring out, okay, how do I go and cleanse that data and or figure out a different strategy on how to make sure the data is cleansed from the get-go, I think is one decision point in terms of sort of deploying a data ops, strategy in your industrial transformation.
Thank you very much. So that was it from the questions from our audience. So of course, if you have more questions, feel free to either reach out to Tony directly or to me. One of our participants already reached out to one of your colleagues, so I think that is fine as well. So thank you very much for the presentation and for the inputs. And we will.
Thank you very much, Robin. I really appreciate it. What I'd say is if you're online, please check out the video and white paper we have on our Partner Expo. And we hope you will continue the discussion with us after this meeting. So please reach out. We'd love answer any questions you might have and look forward to hearing from you. Thanks again, Robin, and the rest of the team.
Thank you very much. Absolutely. So up next is our presentation from Ari Almquist. He's the Group Vice President for Innovation and Integration at Moog. And his presentation will be about digitalization enables out of factory automation. And he should be with us also in a second. Okay. There he is. Yep.
You